Hey, in this video we'll be talking about removing elements, erasing them from a vector container. I'm in Visual Studio and I have just a start of a project here. I've just got like my boilerplate, but then I also added a class. And so this class is just going to represent objects. I don't really care what they do, but they're going to have some information stored in them that's special. And they can be used like here's the constructors, so I could have a default construct to set the ID to 4, which is just an arbitrary number, and I could use a constructor where I specify the ID number, and then I have some accessor, so I can get that ID number that's stored privately. Okay, so the idea here is that we've seen what vectors can do, and I want to see how to kind of manage the elements that are in a vector. So I'll start off with including the vector header. We do need that. And then I can go into my main function or anywhere else I can declare variables and make a vector. So here I'm going to make a vector of, I'm going to use my class pointers so that I can manage these objects so that each one is unique. I'm going to use this as kind of a reference type. So here is my vector, so let's just call it objects, and is going to hold pointers to some objects. Let's say we have a loop. Let's go through 10 elements and create these objects. So I need my class pointer. This is a new object. And I'm going to use the new operator and my class. And then I can specify, depending on which constructor I want to use, either the default one, I leave this blank, or the one that takes an ID number. I can throw the ID number in here. So let's do like I plus 1. So it'll start at ID number 1 and go to ID number 10. So we create that object and then we want to add it to our container using pushback. Push back this new object. There we go. And then just to match what I've done here, I have a container. I have new objects that I've added to that container. So here's the new operator. I should have a matching delete somewhere. So before my program ends, I'm going to go through this entire container. I know that objects, the container, knows how big it is, so I can just ask it. And I will delete each object, and then at the end, clear it. And then it's completely empty again if I wanted to reuse that vector. So my memory management here is fine, it's good. But sometimes during the course of a game or a program, you have these dynamically allocated objects and you store them in a vector and you want to manage them. You want to maybe like remove some from that container. And it's not as obvious as it might seem. So there is a function in the vector class. So objects.erase. There's an erase function, and this is the one that actually gets rid of an element in the container. But you can't just say, I want to erase element 4. That doesn't work. Instead, this uses what are called iterators. And iterators are a way of walking through a container, and they're a little more general than using like a number to refer to them. So iterators are great for all sorts of different containers when you know that they act like a container, but they don't necessarily have indexes for all of their elements, then an iterator is important. But for us, we don't care that much because a vector can be treated a lot like an array. It uses indices. So instead, if I wanted to get an iterator, I could say objects.begin. Objects.begin is the first element, is the iterator to the first element. And vector iterators have a special operator overload with plus, which is really nice. So I can just say objects.begin plus 4, and that will get me the equivalent object for element 4, 0, 1, 2, 3, 4. Just iterating to that element and then erasing it. So it's a little weird thing to have to think about. Also, what's happening here is kind of dangerous because if I just plain erase this object, I haven't called delete on it. It's removed from my vector, from my container, but the memory is still allocated. So that's a memory leak right here. So what I need to do first is usually delete the memory there and then erase it afterward. But I'll show you, because we might want to do that for different objects based on a criterion, I'll do this in a loop instead. So let me get rid of this. Let's say careful. That leaks. Okay, so let's say we have a part of our game where maybe two objects have collided, or an object hits the edge of the screen or gets destroyed by the player or whatever, and I want to delete it or get rid of it. Let's say we're going through all of our things. I less than objects.size plus I, there we go. Okay. And then we have some sort of criterion. Let's say if the object ID number is, let's say, greater than 3, and the ID number is less than 6, right? So some way of determining that some objects need to be affected by what we're doing here. So if they're within this ID range, I'm going to try to remove them from my vector. So I will do objects.erase, and I need an iterator. So I'm going to do the objects.begin, and I'll add some index, which is index I, right? So this will remove that ith element, but I also need to remember to delete it. I don't want a memory leak. So let's delete objects I before we erase it. Okay, so great. If I was going through this entire loop, I would find some elements like if it has an ID number of 4 or 5, then it would get affected by this. I'll delete that object because these are pointers that I'm storing here, and then remove it from my vector. Now, there is a kind of subtle bug here, and we'll see it if we run through this. Let's say cout deleting ID, let's say object with ID, and this is going to be objects I get ID. Okay, so how many elements am I going to end up deleting here? I should be deleting the ones with ID 4 and ID 5. Okay, but it only says I deleted 4. Why is that? So look at what happens. If we walk through this logic, we're checking to see if it's either 4 or 5. We will delete it. We will erase it from the vector. All right, so that's good. So I, at that point, once we find the first one, I is going to be, what is it, like 3? Because we're referring to the one with the ID of 4. So I will be 3, and then when we go through the loop again to get to the next object, I is going to be incremented. So we're moving on to the next object, but I just erased one from the container. It doesn't exist anymore, so all of the other ones kind of slid down into its place, dropped down into that previous slot. So by incrementing the index, I have just skipped over an entire object, and that's why I'm only getting one of them deleted here. That's not what I expected, and that's not what I wanted. So it has to be kind of an awkward pattern where I check to see if I'm going to delete something. If I do delete it, then I don't want to increment. And there are a couple of ways to go about this. Some people do a decrement here. Sometimes you'll see this. Let me get rid of this and put an else so that we only increment if we didn't erase. And this will fix that problem. So let's try it out, make sure. Okay, deleting ID 4 and ID 5. Looks pretty good. Great. Okay, so that's the concern that you have to have when you are erasing things from a vector. Make sure if you're doing it in a loop that you're not skipping over objects. There's also an issue where if you were using iterators, erasing an object from the container could invalidate the iterator. So keep that in mind once we work with those. All right, so keep those in mind when you're removing elements from a vector. Be careful. Stay safe. See you later.